share my screen. Today is, I made a mistake here. Project 3 is due not on Tuesday, but on Wednesday, so the 14th. Homework 8.1, that's that homework that's just on percents, is due today. Homework 8.3, that's the one on simple interest, is due on Wednesday. Before we get started, does anybody want me to open my labs and look at any of those homeworks? Or does anybody have any questions on the project that's due on Wednesday also? So far we're liking percents and simple interest. Not hearing any questions or concerns, then today we're going to go and look at something that's a little bit more involved. That's called compound interest. And I guess before we get started looking at compound interest, I'm wondering, have any of you heard of compound interest? Having interest compounded. When interest is compound, what happens is you can earn interest on the interest. Usually you earn interest in simple interest account and just the money that you put in the principal. With a compound interest, what happens is you earn interest on the interest. The way that is done is periodically. So at a different time interval and regularly, the interest is added to the principal. And once it's added to the principal, you can earn interest on it, so that you can earn interest on it. Conversely, if it's a loan that's compounded, you have to pay interest on the interest that accumulates. When I talk about that idea of periodically, some words that you hear are if something's compounded annually. And if something's compounded annually, it's once a year. And we're going to be introducing a new variable. That new variable, n, is the number of times per year, or the number of compounds per year. And so if I'm compounding annually, once a year, it tells me that n is 1. Next, you might hear of something being compounded semi-annually. And semi-annually is twice a year. And so if it's happening twice a year, that variable n will be 2. Quarterly will mean 4 times a year. And so n is 4. Then the next couple, I think, are relatively straightforward. If something happens monthly, how many times a year would that be?
12.
12, beautiful. So that's 12 times a year. And so we'd have n be 12. Next would be weekly. And anybody offhand know what's considered the number of weeks in a year? 52. So weekly would be 52 times a year. And N would be 52. And then the next one, daily. It's usually accepted that there's 365 days in a year, but we're going to be using a banker's year. And a banker's year has 360 days. So it'll be 360 times a year. And I think that being a banker's year is 360 days kind of harkens back to like pre-computer, pre-calculator days when a lot of this work had to be done by hand. And so 360 was just an easier number to work with. Before we start looking at the formula for compound interest, I'd like to look at an example where rather than using the formula, we do the work out by hand so you can wrap your mind around what this idea of compounding means. But we're going to find that we won't have to do this much work again. We'll use a formula instead. But before we do that, before we look at those compound example that we're doing by hand, I'd like to have something to compare it to. And so I'd like to compare it to what we've been working with so far, a simple interest problem. So let's look at one more example that uses simple interest. And we're going to say that we invest. I'm going to try to make the numbers nice and even for us. $1,000 at 5% simple interest. For 3 years. What's the future value? Again, this is very much like what we were doing on Friday. Our future value formula says that A is equal to P times the number 1 plus RT. Remember, I had asked that you please, before you do these problems, write your formula. And then identify your variables, P, R, T. What would P be? Anybody?
1,000.
Beautiful. What's R? What's our rate?
0.05.
Beautiful. 5%, but it's really important that we write that as a decimal, 0.05. Great. And what's our time? Again, in years would be 3. So when we substitute in then, our future value is our principal, 1,000 times 1 plus our rate, 0.05 times 3. And so I'm going to ask you folks to please take a minute and calculate that and tell me what you get. Does anybody have an answer yet?
I got 1,150.
Beautiful, $1,150. Great. So if I ask how much interest was earned, does everybody remember, in order to find that, we're going to take that future value, our final dollar amount, and subtract our initial dollar amount, what we invested, and we get $150 interest. Is everybody all right with that formula?
Yeah.
Because for the next example, we're going to actually have to use that 3 times. For the next example,
Can you scroll down for a minute real quick,
sure,
please?
let me know when you've got this. I don't want to go on to the next example until everybody's got this, because this is kind of the lion's share of what we need to think about differently when we
Okay.
compound.
I'm all
Okay.
set, thanks.
All right, so let's look at compounding. First, doing it the slow way, the longhand way. So this time, let's say we're going to again invest $1,000. Again, for the same amount of time for 3 years. This time, though, it's going to be at 5% interest, compounded annually. And so over here, that idea of compounding annually means that at the end of each year, the interest is added to the principal. And so what we have to do is we have to, at the end of each year, figure out for year 1, at the end of year 1, what's my future value? That will become my principal for year 2, and so on. So if I look at year 1, future value, A equals P times 1 plus RT. Our principal is that starting $1,000. Our rate, just like before, the 5% is 0.05. But since we're stopping at the end of each year, we're going to look at the time being 1 year. And so at the end of that first year, when I substitute these numbers in, I get A is my principal, 1,000, times in parentheses 1 plus 0.05 times 1. When we work that out at the end of the first year, we have $1,050. We earn $50 interest combined with our principal. That would be $1,000. So now for year 2, when we use A equals P times 1 plus RT, this time our principal is that new amount, the $1,050. That's why we have to stop after a year, because after each compound period, here it's a year, we've got a new principal. Our rate will stay the same, that 5% or 0.05. And again, because we're compounding annually, our time will be 1 year. So at the end of year 2, we're going to take that $1,050 times 1 plus 0.05 times 1. And at the end of year 2, when we multiply that out, we have $1,002.50. And we'd have to do that again for the third year. But this time, when we look at A equals P times 1 plus RT, this time our principal was that value at the end of the second year, $1,102.50. Again, our rate stays the same. And because we're compounding annually, our time is 1 year. And so at the end of the third year, A, our future value, is P, the $1,002.50, times the 1 plus R 0.05 times T1. And here, let's find it to the nearest cent. And so to the nearest cent, this would give me $1,157.63. And so this would be my value after the 3 years. What would be my total interest after the 3 years? Well, that's my value, my $1,157.63 minus the money I put in, which is $157.63. Now I want to stop for a minute. Does everybody have all of that down? I want to compare this to that simple interest problem that we did at the beginning of this page. So notice this is $1,000, 3 years, 5%. Our simple interest was $1,000, 5%, 3 years. And if I compare simple interest, we had $150 interest. Compound interest, we have $157.63 interest. It's more. Did we do anything different? No, we put our money in the bank. It's just because that word compound was at the end, we earned more interest. And again, if I'm compounding annually, I've got to figure that out at the end of each year. And if I'm compounding annually, my time is 1 year. Once a year. Everybody all right with that idea that, well, at the end of that year, the interest is added and my principal goes up. And doing it once a year for 3 years, I had to go through and find that future value 3 times. I'd like to look at another example that's going to be a little bit different, similar yet different. Next example, let's say we want to again invest. It'll be that same $1,000 for that same 3 years at that same 5% interest. But this time, let's compound monthly. So let's see. If I'm compounding monthly, that means I'm doing it 12 times a year. And if I'm compounding it monthly for 3 years, that means I'm going to have to go through and do all of this work instead of 3 times, 36 times. Does anybody want to have to go through and use that future value formula 36 times?
No.
No. When we did it annually, at the end of, for each period, the time was 1 year. This time, if we're doing it monthly, the time would be 1/12 of a year. So we'd be also working with fractions. So because we don't want to do that work, we're going to introduce a new compound interest formula. And with this formula, A is equal to P times, we're going to have 1 plus, it's going to be R over N. Because if I'm doing it less than a year, my time is a fraction determined by the number of compounds per year. And that we're doing this over and over and over again. If you notice in that last example, each time we were multiplying by the same thing. It's just we had to do it 3 times. So to show that we're doing it, we're multiplying it by that quantity repeatedly, we're going to use an exponent. And that exponent is going to be n times t. So just like before, P is going to be my principal, my starting amount. R is going to be my rate as a decimal. T is going to be my time. And we're always going to think of time as being in years. N is going to be the number of compounds in 1 year. And then, because I can only personally handle a certain number of parentheses in any given formula, I'm going to go over here and add NT. And that's going to be the product of N times T. And so that's, you'll be given that formula. You don't necessarily have to remember it, but you have to remember what things stand for. In the given example up above, our principals are $1,000. Our rate is still that 5%, that 0.05. Our time is still the 3 years. But if we're compounding monthly, N is 12. And so that exponent N times T would be 3 times 12, or 36. To this point, is everybody comfortable?
Yeah.
So that substituting in A equals P times 1 plus R is 0.05 divided by 12, close parentheses, and I'm going to just raise that to the 36th power. Again, it's easier if you go ahead and take that time to multiply N by T before you begin. Oh, Lord. And I said P is 1,000 and I didn't write 1,000. Now with your calculator, I would type that in as 1,000 times. Use that parentheses key, it's very important. And then inside parentheses, I'd type in 1 plus 0.05. And then to get that fraction bar, I'm going to use my division key, divide it by 12. Then I'm going to close my parentheses. Does everybody remember to get an exponent? We'll use that caret up button. Some calculators, depending on the brand you have, might be y to the x instead. And then I'm going to type in that number 36. And so after that, I'll hit my equal sign with my calculator then. Let me type 1,000 times open parentheses 1 plus 0.05 divided by 12, close parentheses. I'm going to caret up to my exponent, type in 36 and hit enter. And is anybody else getting for their future value $1,161 and to the nearest cent, 47 cents?
Yeah.
And so this time, the interest that we earn would be that amount minus the $1,000 that we put in. And so our interest is $161.47. And if I compare this to what we did compounding annually, do you see that the more frequently you compound, the more interest you earn? And so it's not a lot more, but it's still more. And we're not doing anything different other than putting in our money into an account that compounds monthly instead of annually. So does it make sense that if I were to compound weekly, I'd make a little bit more interest? If I were to compound daily, that would be 360 times a year. I'd make more interest. If I were to compound instead of every day, what if they did it hourly? Then it would be 24 hours times 360 days. That would be more. Well, couldn't they do it every minute? That would be even more, right? How many minutes are there in a year? Well, how about every second? Wait a minute, how about every half a second? Or even smaller amounts of times? And that gets us to the idea of compounding continuously. Instead of monthly, weekly, daily, hourly, every minute, every second, we're saying that the interest is constantly being added to the principal. And you're going to see this one on a couple of homework problems. In order to come up with the formula for this, we need to introduce a new letter, E. And E is not a variable, but rather a constant. It's kind of like, I think everybody's familiar with the idea of that symbol pi. And while it doesn't look like a number, it always represents the same number. E represents a number that's called Euler's constant. And I have to apologize. I can never remember E to very many digits. So let me go ahead and tell you that E is equal to approximately 2.7182818. And it's actually a non-repeating decimal. It'll go on and on and on. It's defined by the idea of taking a limit, which is a very much calculus concept. So we're not going to really look at the definition, but we're going to know that for compounding continuously, we need to use that. When I compound continuously, my formula is A equals P times E to the N, E to the RT. Where again, P is the principal, R is the rate as a decimal, and T is the time in years. And E is not a variable. E is that constant. So if we go back to that example we've been using, where we invest that $1,000 at 5%, but this time let's have it compounded continuously for those 3 years. And again, I'm only going to use this formula, A equals P times E to the RT, when I see that word continuously. And because I want to compare the dollar amounts, we're going to use that same principle, $1,000, that same rate, 0.05. I have to apologize. I'm switching from uppercase to lowercase. R is going to be the rate, whether it's uppercase or lowercase. T is going to be the time in years, 3. And again, because we're compounding continuously, we have no need for N. So this gives me A equals P is 1,000 times E to the 0.05 times 3. Now, here's where things get a little interesting, because E is kind of hidden on your calculator. Could everybody please take your calculator and look at it? If you've got the same Texas TI 30X that I have, in the upper left-hand corner, you have a different colored button, second. Below that, you have a button log. Below that, you have a button LN. I want you to look at the LN button, but not really at the button, but above it. Above it, written on your calculator in the same color as your second key, do you see there's that letter E with an exponent of X? That button raises E to a power. So on my calculator, to do this problem, I would type that 1,000 times, and then I've got to press that second button, followed by that LN button. And when I do that, if everybody could please take the calculator and type 1,000 times second LN, do you see that it immediately says I'm raising E to a power? And it opens those parentheses for me already. So then I'll type in my 0.05 times my 3, close my parentheses, and hit equal. 0.05 times 3, close parentheses, equals. And now my future value is $1,161.83.
I get an error.
You got an error. All right, then what I'm going to do is I'm going to stop sharing for a minute.
Yeah,
Yeah.
I did too.
And I'm going to ask you to please, one of you, turn on your camera and show me what your calculator says, please.
Oh, I
Sure.
just clear mine.
Okay, do me a favor, even though you cleared it,
Uh-huh.
turn it on, show it to me, and arrow up so I can see what you typed in. You arrow up, it should bring you back to that last line that you typed. And does it look 1,000 times E, caret up, open parentheses, 0.05 times 3, close parentheses? William, you're muted, so I can't hear you.
I know what I did wrong. I hit enter and I shouldn't have hit enter.
Yeah, you don't do that until the end.
So
I don't
then
have a calculator. Oh, sorry. I don't have a calculator that can do that, but I'm
What-
just
what cal-
TI 30XA.
Can I see your just, okay. You don't have an LN key?
I do, but when I do 1,000 times second LN, it goes to error.
Okay, when you look at your LN button.
Yeah.
Above it, do you have E to the X?
Yep.
Okay, so try typing in for me, please, 1,000. Then just second LN,
Also an error.
also an error.
Yeah.
Can you hold it up so I can see the display, please? Oh, you don't have a second line of display. Okay.
No.
Try going, parentheses.
Okay.
0.03 times 5. Close parentheses. Then go second ln
That worked.
equals. Then times 1,000. Equals.
Well, yeah, there I got 1161.83.
So with your calculator, because it doesn't have that second line of display, you're going to have to do that. You're going to have to type it in where you do the right type, figure out what the exponent is, then press the second ln, and then multiply that answer by the principal. Okay.
All right.
So you're
Thank
going to
you.
have to do it in a reverse order.
All right.
Anybody else have problems like those? If not, let's go through and find the interest, which would be that $1,161.83 minus that $1,000 that we started with. And so we made $161.83 interest, which isn't a lot more interest, but it's still higher. And compounding continuously would give us that maximum amount of interest. Let's look at a couple more just compound problems. For the next example, let's say we're going to invest, let's say $5,000 at 4.5% interest. Let's say it's compounded quarterly. And let's say we're going to do this for 10 years. Let's find the future value. And let's find the interest. And again, we're using the formula A equals P times 1 plus, and again, I don't see that word continuous, so I'm going to go back to that compound formula. 1 plus R over N to the NT. I'm going to ask you guys to tell me what P is, what R is, what N is, what T is, what NT is, and then your future value. I'm going to give everybody a couple minutes to work on this one. How are we doing?
Good.
Good. Did anybody else get that at the end of the 10 years, they'd have $7,821.88. And so
Yeah.
the interest earned is $2,821.88. Please, if you did not get that, speak up because I want to make sure that everybody's all right with typing this into their calculator. Places where common mistakes occur, make sure that you notice that that rate was 0.045. That quarterly meant 4 times a year, so your exponent is 40. Let's try another one. This time, let's say we're doing that same $5,000 at that same 4.5% interest. But this time, let's have it compounded continuously. For those 10 years. And again, this is A equals P E to the RT. And this one, it's actually less typing, but you just have to remember to use that second button. And again, if your calculator needs to, sometimes you need to find that exponent first. Is everybody getting this time a future value of $7,841.56, so that their interest is $2,841.56.
Yeah.
So next problem, I think it's going to take more than the 3 minutes that we have left. And so as much as I want to go further, I don't want to race. So I am going to stop here. Going back to the beginning, the compound interest homework isn't due until a week from today because again, I expected that it would take more than 1 day to get fully through it. So we'll pick up from here next time. That homework that is due on Wednesday is strictly simple interest. So hopefully nobody has a problem with that. I'm going to stop sharing my screen and ask if anybody has any questions on anything that we did. Again, I'm not going to ask you to memorize those formulas. You will have that formula sheet. And now I have to apologize. I think I had promised that I would upload that to Blackboard and I didn't. I will make sure that I do that today. Any questions?
Just your attendance, I think you skipped me.
Kayla, I apologize. I didn't see your name there. You're there now. Sorry about that. William, I got you when you came in. Is there anybody else? If not, have a great day, you guys. We'll see you on Wednesday.
Bye. See you on
Bye-bye.
Wednesday.
Bye. Have a good day.
You too.
Thanks.
Sienna and Vinnie McKenzie, do any of you have a question on anything? If not, we'll see you Wednesday. Bye-bye.